Okay guys, welcome to part 2 of the binomial theorem. There's just a couple items you're going to need in order to do this video, so I'm just going to go through them. You're going to need your really big diamond pen. You will also need a freaking cup holder for your really big diamond pen. You will need some seeds in case you get hungry, and maybe some white glue in case your life falls apart. Okay, and you will also need your notes. Okay, now that that's aside, you can get rocking and rolling. So we left off with, we left off with this example last time. Okay, and I kind of fudged my way through the general term formula. Didn't really look at it ahead of time. So you can sort of ignore what happened there. And we're going to switch over to this page. Now, we're going to avoid doing this warm-up question because we're a little lazy. You can always go back to part 1 and watch how to do these ones if that's the case. Let's go ahead and look at this general term thing. So, I apologize, but that's all wrong. Well, it's not wrong. It's just a different formula than the one we use on the exam. So, the one we use on the exam is this one. And I got this wonderful blue ink on blue paper, so I hope you guys can see it. But yeah, this is the general term formula for the binomial theorem. So they might ask you something like, what's the 8th term of this expansion? Okay, so we got t for term, and then k plus 1, which we'll explain in a second. And then we got our usual combination, so nck, and then a refers to whatever the first thing is in the binomial. So if you look at this question, it'd be 2c to the 4, that's my a term. My b term is -1. And then we got the power n minus k and k. Okay, so this is on your formula sheet. So let's go ahead and, what we'll do is we'll take this question here, and it says, let's look at the third term. Well, let's go ahead and find the third term using our formula. Okay, so one thing to watch out for, so definitely watch out, is if you're looking for term 3, our formula is term k plus 1. Okay, so when I say term 3, that means that this has to equal 3. So generally what I like to do, because I'm not so bright, is I'll take my k plus 1 and I'll set it equal to 3, and I will solve for what k is. Okay, so if I'm looking for term 3, k has to be 2. Okay, the reason I care about that so much is your formula uses k and not k plus 1. So it's just a little quirk in the formula. There's a reason for that. It's not really worth getting into, but that's how you're going to have to do it. You're going to have to solve for what k is. Okay, once you have that, n is just going to be whatever the power is here. So in this case, we got n equal 3. And we got our a term equal to 2c4, and your b term is -1. Okay, so now you can write your formula. So term 3, I'll just write out the general formula. It's a to the n minus k, and then b to the k. Okay, so term 3 equals, so n is 3, c, and then k is 2. Use brackets, your a term is 2c to the 4. And then n minus k. So you're going to go 3 minus 2, and you're going to get 1. And then your b term is -1, and it's raised to the power of k, which is 2. And then you can clean that up. Oh boy, what's 3c2? 3. So right, term 3 equals 3 times, I guess we're just going to write 2c to the 4, because it's raised to the power of 1, nothing changes. When you take -1 and you square it, you get +1. So now you can kind of clean it up, multiply all the numbers together, and you're going to get 3 times 2 times 1, so 6c4. And you just went and found the third term in that expansion. Okay, I'm going to save that for later, just like how I'm saving my seeds for later. Let's flip the page. All right, now we're rocking and rolling. So, determine the 7th term in this expansion. Okay, so that is a 9, pretty sure. Let me just double check here. Yeah, it's a 9. That's a 9. Okay, that's a 9. So review from yesterday. This has 10 terms total. Okay, and if you were to expand it using the combination method of getting the Pascal's triangle, you would be starting with 9C0, 9C1, dot, 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 until you get to 9C9 for your coefficients. Okay, but we don't need to do any of that. We're just looking for the 7th term. Okay, so I'm going to write my general formula. This one's straight off the formula sheet. Okay, so you don't need to worry about that. It's straight on the formula sheet. But you do need to worry about, well, what's k plus 1? It needs to equal 7. So k plus 1 has to equal the term we're looking for. Okay, so that means that your k value is actually 6. It's really important. People seem to mess that up frequently. Your n is just whatever the power is. So n is 9. Your a value is whatever is the first thing in your binomial. So a, in this case, is x, and your b value is whatever the second thing is, including the negative sign if there is one. So b is -3. Okay, so now I can write term 7 equals n is 9, and c, k is 6. My a value, put it in brackets, and it's n minus k. So 9 minus 6 is the power. Your b value is -3 raised to the power of k, which is 6. Okay, so that's a good first step. Grab your handy dandy calculator, go 9C6. Oh my goodness. Oh, 84. Okay. So you get 84. X to the power of 9 minus 6 would give me x to the 3. And then, oh, I'm not doing, hell no, I ain't doing 3 to the power of 6. So 3 to the power of 6, that's 729. Now, because it's an even exponent and we got a negative in there, it's going to be positive 729. Okay, now you can't leave your answer like that. You got to clean it up. You'll have your calculator, so I'm going to go 729 times 84, and I get that number. I get 61,236, and then x to the 3, and boy, aren't we thankful for the general formula, because that's the answer. All right. Easy peasy, lemon squeezy. Flip the page over. Now we're rocking and rolling. It says determine the 5th term. This one has fractions, so I thought it would be a blast. Remember, if your life's falling apart, you got some white glue, stitch it back together. Oh no, where's my diamond pen? Oh my goodness, guys. I can't find my big diamond pen. I think someone stole it. Oh no, wait. It's just in its cup holder. Ha! Silly DeMuro. Okay. Gotta have my lucky diamond pen. Unfortunately, the pen doesn't work anymore, but the diamond is just so valuable. Okay, we better get rocking and rolling here. Enough jokes. So, 5th term. So, write the formula. There it is. You're finding the 5th term. So, go ahead and go k plus 1 equals 5. So k is 4. Wonder if everybody gets this wrong because they think it's so easy that they skip it and then they go and get it wrong. But yeah, don't miss that step. N is 7. And my a value is whatever the first thing is in the binomial. So it's y over 4. My b value, include the negative, is -2 over y. Okay, so I'm ready to pop it into the formula. And then I'm going to have some fun cleaning up. So I'm going to go 7C4, and the a value is y over 4 raised to the n minus k. So n is 7, k is 4. Let's take a shortcut and write 3. Okay, 7 minus 4 is 3. And then we go the b value. So that's -2 over y. It's raised to the power of k, which is 4. Okay. All right. Now I just have to sort of, do some cleanup, I guess. 7C4 is 35. Just recopy the t to the 5. And then I got y to the power of 3 over 4 to the 3. I should know that, but 64? I'm just going to double check. 64. Don't doubt yourself. Now you got a negative raised to the power of 4, so it's going to be positive. And then 2 to the 4 is 16. And then y to the 4 is y to the 4. Yeah. Then you're sort of expected to be able to clean that up. It's not that hard. My light's a little off here. There we go. Okay. So, I mean, you can cross-reduce here. You can divide them both by 16, actually. Right? So, 16 goes into 16 once and into 64 4 times. And then you got 3 y's up here, which is going to cancel 3 y's down here, leaving you with just a y. So, now we have 35 times 1 over 4 times 1 over y. Okay, now 4 doesn't go into 35, so I'm going to finish cleaning it up. I'm going to go 35 times 1, get 35, and in the bottom you have 4y. That's your fifth term of that bad boy. Well, that was an ugly question, but using that formula made it quite a bit easier. All right. This is my fine mahogany desk. Ooh. Just kidding, it's actually fake. Determine the middle term. Now, boy, when they get tricky with the language there, you guys are going to be suffering. So we need to think here. So middle term would mean the middle, okay? So to do that, we need to think, well, if it's raised to the power of 10, this was yesterday's material, there's 11 terms. There's always one more term than the power. So if there's 11 terms, there's actually a middle term. Now the question is, which one's the middle term if you have 11 terms, so an odd number of terms? Okay, so if you, let's just extrapolate, or let's go down to a small data set. Let's say we got 3 terms and they're A, B, C. The middle one is B, right? You got the same number of terms to the left as you do to the right. Now, how do I find that, like with, numbers? Okay, well, if I go 3, oopsies, if I go 3 divided by 2, that tells me that the 1.5th term is the middle term. Well, that doesn't make sense. So it means we got to round up. So the second term would be the middle term. Okay, so I figured out my formula. I just take how many terms I have, I divide by 2, and then I round up no matter what. Okay, so if I have 11 terms, which one's the middle term? Well, I go 11 divided by 2. That would give me the 5th term, which doesn't make any sense. So I'm going to round up. It's the 6th term. That would be the middle term. Okay? Man, and if you don't believe me, I'm more than happy to write out 11 terms. I'm just going to use numbers. I hope that doesn't confuse anyone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's count. 1, 2, 3, 4, 5, 6. There is the 6th term. If it is indeed the middle term, there should be the same number of terms to the left as there is to the right. So to the left, I got 5 terms. To the right, I got 1, 2, 3, 4, 5. So clearly it's the middle term. Okay. That was a lot of work to figure out that we're looking for term 6. But if it comes up in that language, you'll know how to deal with it now. Okay? So actually, I kind of don't even want to do this question. I mean, it's very similar to the other ones we've done, but what the hell, we're almost there. So here's the formula. I'm going to write it out every time, so just bear with me. Hopefully you memorize it. That would be the best case scenario. So now you can go k plus 1, SE equals 6. So your k term is 5. Okay, your n term is the power, so it's 10. You got the power! Okay, keep going, DeMuro, don't stop. Okay, so we're going to go term 6. I am going to take some shortcuts. I'm not going to write out A and B, but this is A, and this thing here in the box is B. So we got 10, C, 6, 5, 10C5, K is 5. Okay, good thing I wrote it down. A is 2x, and it's raised to the n minus k. So that would be 10 minus 5, so 5. And then b is negative 1 over 2x raised to the power of k, which is also 5. Boom. All right, grab your calculator. We're going to figure out that combination. 10C5, 252. Oh gosh darn it, I forgot to write the term 6. There. All right, now 2 to the 5 is 32, 2 raised to the power of 5, and then x raised to the power of 5 is x to the 5. You have a negative raised to an odd power, so it's going to stay negative. Okay, and then 2 to the 5 again is 32, and x to the 5 is x to the 5. It's just all in the denominator. Boom. All right. Some stuff cancels, like 32 divided by 32, well, that's 1. And x to the 5 divided by x to the 5, that's 1. So you're just left with a negative 1 times 252. So seems kind of anticlimactic. All that work to get negative 252. Sometimes the variable disappears in the expansion. All right. Neat. I'm starting to get hungry. I might have to eat my seeds. Flip it. Let's see. Do we want to do this? Because I got way more questions in this package than we really need. So we're not going to do all of them. All right? Sorry if I disappoint some of you nerds. We're not going to do every single question. All right. Let's see. The next two questions we have to identify. Yeah, we're going to do this one. So this is the question type where they give you some information like, oh, find the term containing x to the 14 in this expansion. This one's not exactly an exact science. No, it's not an exact science. There's going to be a bit of guess and check involved, but not an exact science. But it's going to be educated guessing and checking. Okay, so I'll show you what I mean. You sort of have to start somewhere. Okay, so you got to see, well, when I start expanding this thing, what's the pattern? Okay, so we're actually going to find term 1 and term 2, and then we're going to sort of use some educated logic, and we're going to hopefully get to the answer and figure out which term has x to the 14 in it. Okay, so term 1. Now, this is just the expansion, right? This is what we were doing the other day. So, n is 11. There's going to be 12 terms. There's always one more than the power. Okay, and if I'm just finding term 1, I'm using the factorial method, right? It's going to be 11c0 for term 1, and then my a term, whatever it is, in this case it's 2x, and then negative x squared, that's my b term. And then remember, the powers, the first one starts on whatever the power is, 11, and the second term starts on 0. Okay, now we're going to sort of figure out what this is, and here's the thing. We don't care about the coefficient so much in this case, right? They just want to know, find the term that contains x to the 14. So we're just going to focus on what happens to the x's for now, okay? After, when we figure out which term it is, we'll actually calculate out the term, okay? So that's important to note. So what happens to the x's? Well, you're going to get an x to the 11, and you're also going to get, well, x squared raised to the power of 0. That goes away, okay? So this term has an x to the 11 in it. Well, let's find term 2. Again, I don't really care about the coefficient, but just for practice, term 2 would be 11c1, and then the a thing, power goes down by 1, and then my b term, and the power goes up by 1. Okay, so just focus on what happens to the x. So we get an x to the power of 10 times x squared raised to the 1, so x squared. So this one has an x to the 12 in it. Could it just be that every time I go up by one term, the power on the x is just going up by 1? And the answer is yes. So that's exactly what's going to happen. So my prediction is my term 3 is going to have an x to the 13, and my term 4, ding, 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 that's the one that's going to have an x to the 14. Now, that's educated guess and check, right? Like I noticed the pattern, and then I homed in and said it's probably term 4. Okay, so I'm going to go ahead and actually calculate it, because it does say find the term, as in like, well, it's actually sort of unclear if they want to know just term 4 or what the actual term is. For practice, we'll actually go and find term 4. Okay, I guarantee you it'll be much more clear on the exam. They don't leave the language vague. So okay, doing term 4, I'm just going to sort of use what I know from yesterday. So term 2 is 11c2. Okay, and then term 3 would be 11c2, so term 4 is going to be 11c3, and that's going to be 2x raised to some power. So I'm just going to go back. Term 2 was power of 10, term 3 would have been 9, term 4 is going to be raised to the power of 8, and then my b value is negative x squared, and it's going to have a value of, let's see, it was 1 on term 1. Oh, hopefully that didn't affect my video. My battery just went low. Okay, so on term 2, it was 1. On term 3, it'll be 2. Term 4, it'll be 3. Okay, and then we can compute that out. I'm just going to leave it at that because the question's kind of vague, and I'm just happy that you found out what term it is. Okay? Wunderbar. Next one. So I mean, we can do questions like this, and until it's time for biology class or something boring like that. Let's see. So find the term that has no x's. Okay, very similar question. Okay, there's no right or wrong way to do them. There's just easier and harder ways. Okay, so again, a little bit of educated guessing and checking is going to go a long way. So I would say go find term 1. Okay, now this is raised to the power of 12. So n is 12 and there's 13 terms. I like to write that down. So that's great. So my formula, remember, if you use the combinations, it's going to be 12c0. The a value is 2x to the 4, and it starts on 12. And then the b value is negative 1 over 2x squared, and it'll start at 0. Okay, so anything in the power of 0 is 1, so this goes away. And again, I'm just interested in the term, and that has no x's, so I'm not going to worry about the coefficients right now. I'm just going to go 4 to the power of 12. So when you go to power to a power, you multiply the exponents. I mean, if you don't remember that, good luck to you. So this has an x to the 48. I'm now going to find term 2 so that I can establish, well, what's the pattern? What is it going up or down by? So let's see. Term 2 would be 12c1. And then again, I got 2x to the 4. This time instead of power of 12, it's power of 11. And this one is now like that, and it's raised to the 1. Okay, so on the top, I'm going to have an x to the 44. That's 4 raised to the power of 11. Now, in the bottom, okay, so this is in the denominator, so I'm just going to write 1 over. And again, I don't care about the sign. I'm just going to focus on what happens to the x squared. So x squared raised to the power of 1, still just x squared. Okay, now this is quotient law. So what happens is, as you go 44 minus 2, and you have x to the 42. So what happens? It went down by 6. All right, it went down by 6. So which term will have no x's? Well, I can sort of just count down. So this is term 2. If I subtract 6 again, well, the next term would have an x to the 36, and then the next term would have an x to the 30, and then an x to the 24, and an x to the 18, and then just subtracting 6 every time, right? X to the 12, x to the 6, x to the 0. That would be no x's. Which term is it? Well, this was term 2, right? 3, 4, 5, 6, 7, 8, 9. It's term 9. Is that a corny way of doing it? Maybe, but it works, and I'm very confident in my answer. Now, because it's very subtle language here, but this one says find the term. So as in, what is the actual term? We need to compute it. The other ones, well, it also said find the term. So we're going to actually compute it, just for giggles. And we can use our general term equation because it's going to be too much work to do it the other way. Okay, so if we're finding term 9, right, remember your general term equation is t k plus 1. You already forgot, didn't you? Right, that's why we're going to write it out. It's nck a to the power of n minus k b to the k. Finding term 9, so k plus 1 equals 9. Okay, and then k equals 8. Don't forget that step. I'll stop doing that voice. N is 12. Okay, your a term is, we know what it is, so we're just going to start writing it. Term 9 equals, so n is 12, c, k is 8. My a term, looking up, that's 2x to the 4. It's raised to the power of n minus k. So 12 minus 8, which is 4. And then my b term, is negative 1 over 2x squared. It's raised to the power of k, which is 8. Keep on trucking. Get my calculator. 12C8, it's 495. Okay, and then I'm gonna go 2 to the 4, which is 16. And then 4 raised to the power of 4 is 16 as well, right? You just multiply the exponents. In the bottom, we got a negative raised to an even power, so it's gone. 1 raised to the power of 8 is 1. 2 raised to the 8 is something gigantic. I ain't doing that. 256. 256, I should have known that. And then x squared raised to the power of 8, so 2 times 8 is 16. Okay, so as predicted, we got x to the 16 in the numerator, x to the 16 in the denominator. That goes away. We were expecting that. 16 and 256 will both be divisible by 16. Yeah, so 256 divided by 16 is 16. So that goes away, and this turns into a 16. So just going to clean it up a bit here. I got 495 times nothing but a bunch of 1s left in the numerator. So I'm just going to write 1 over in the denominator. I just have 16. So there's your answer. 495 over 16. There. That's term 9. Wow, what a beautiful question that was. All right. Any questions? No, I don't hear anybody asking questions. This seems to be the same question again. I just do that sometimes to make the booklets thicker to freak you guys out. Honestly, after that, there's really nothing new to learn. So this would be the third question of this type that we're doing. So if you need more, you can come see me. Obviously, do the homework. We made these beautiful homework books for you with the exact, 18 questions you need, plus review, all in that 18 questions. They're awesome. They're amazing. Okay, so I think we're going to sort of skip that one. I'm going to see if anything else catches my eye. A final question. Oh, well, this sounds like a challenge. I like challenges. I'd even bet my snack on it. The fifth term in the expansion contains an a to the 4. Yes, I think we should do this one. So it says determine the value of n. Okay. I think I have this one somewhere. I pre-did it. You can wing it. That usually ends up being a disaster, but let's try. Let's see what happens here. So the fifth term. So term 5 has an a to the 4 in it. Cool. Ooh, I see. Find the value of n. So we don't know what n is. Very nice. Let's try it. So my a value is whatever the first thing is, so a to the 4. My b value is -3 over a. I don't know n, so put a question mark, but can I find k? Of course I can. So k plus 1 has to equal whatever the term number is, so 5. So k would be 4. Okay. Then I'm going to go to my general term formula, which I'm going to rewrite. Duh. It's good for your brain. Helps you remember. All right. That looks good. So I got term 5 equals. So I don't know n. So I'm just going to write n c4. And then a is, a is a to the 4. It's raised to the n minus k, which is 4. And then b is -3 over a, and it's raised to the power of k. All right. Hammer time. Because we got to do some thinking here. If we're going to find the value of n, if we're going to find that value, I guess the question sort of becomes, do we need to worry about the NC4, right? Like this is going to tell us a number. It's going to tell us the coefficient. It doesn't help us solve for n. Okay, we have an n over here. If we can figure out what the n is over here in this part of the equation, that will tell us what the n is here. Okay, so it's a bit of a jump, but we actually don't care about that. Not at all. Okay, and then we can see what happens. So we can write T5 equals, let's clean this up. So I'm going to just write a, and I'm going to distribute the 4, right? I'm just going to go 4 times this, so you're going to get 4n minus 16. And then, oh, well, again, this has no bearing. The -3 has no bearing on the value of n. It doesn't change anything for us. So we're actually going to ignore the 3 and just pretend it's a 1. Okay, and I understand that's a bit of a stretch, but if you really think about it, it does make sense. Okay, so at the end of the day, what we get is we get a 1 over a raised to the 4. And we don't care about the negative either. It doesn't affect the value of n. We're just working with the powers here. Okay, now there's one more piece of information that we didn't use yet. So it says that term 5 has an a to the 4 in it. Okay, so that means that they're not telling me anything else about term 5. They didn't tell me about the coefficients. They just said it has an a to the 4. So when it's all simplified out, I know that term 5 has an a to the 4. So I'm going to write a to the 4 equals all this stuff. And now I can actually solve. This is a wacky question. 1 over this, I hope it's okay if I just write it like that in the denominator. Okay, so let's see, at this point, how am I going to get rid of this in the denominator? I'm going to multiply both sides by a to the 4. That's gone. So on the right hand side, I just have a to the power of 4n minus 16. Now, don't go crazy. Grade 9, you guys learned when you got the same base and they're being multiplied, you add the exponent. There it is. And now you know from your logs unit, well, you got an equation. It's got the same base, right? So then the powers have to be equal. So you got 8 equals 4n minus 16. Add 16 to both sides. You get 24 equals 4n. Divide both sides by 4 and you get n equals 6. And wow, I deserve some seeds. This is a hard question. Yeah. They look like little bed bugs or something. Delicious. Yes. Yes. Oh, very. Get these off my page. Okay. Did he eat them? I don't know. Okay. I think that might have been the last question, guys. I mean, flip it over. I did that funny thing again where I have the same exact question again. So, or is it slightly different? No, it's exactly the same. Same question. Oh, good. All right. So that's no longer the case. That's from the old workbook. You have a supplementary sheet. Maybe in here. Yes. Supplementary sheet here in your booklet. Answers to follow. And you can go ahead and do exercise 8.4, 8.5 in your notes. So thanks for joining me, and bye-bye.